Welcome back. In this video, we are going to solve problem 5.58 that is taken from chapter number 5, Analysis and Design of Beam for Bending, and book name is Mechanics of Material by Beer and Johnston, 6th edition. So statement is draw the shear and bending moment diagram for the beam and loading shown and determine the maximum normal stress due to bending. So you can see this is a simply supported beam AB having pin support at point A and a roller support at point B. And there is a uniformly distributed load from C to D having 80 kilonewton per meter. At point A we have counterclockwise movement of 60 kilonewton and at point B we have 12 kilonewton into meter clockwise movement, and this is wide flange beam which is W250 by 80. So you have to draw the shear and moment diagram. So let's start with the solution. So first step, if you remove this pin support at point A, so you will be having a vertical reaction force which is represented as A, and if you remove this roller support at point B, you will have a vertical reaction force B. So first we will find this A and B by using equation of equilibrium. So first equation of equilibrium is that sum of all moment about point B is equal to 0 and taking the counterclockwise movement as positive. So about point B, the first moment is 12 kilonewton which is clockwise, so I will take it as negative, so minus 12. The second moment is due to this distributed load, and this distributed load when converted into point load, so it will be equal to 80 multiplied by 1.6, and it will act at a distance of half of 1.6, which will be equal to 1.6 divided by 2 is 0.8, so 0.8 meter. So this load 80 into 1.6 into perpendicular distance is now 2 meter, and this is producing counterclockwise movement, so it will be positive. So I will write plus 80 into 1.6 multiplied by 2 meter, and the third load which is producing movement is A, and perpendicular distance is, this is 1.6, 1.2, 1.2 is 2.4, 3 and 4, it will be 4. So 4 into perpendicular distance is 4 meter, and this is clockwise, so it will be negative. So I will write it minus A multiplied by 4, and the last moment is 60 kilonewton into meter which is counterclockwise, so I will write plus 60, and their sum must be equal to 0. So minus 12 plus 80 multiplied by 1.6 multiplied by 2 is 256 minus 4 times A plus 60 is equal to 0. So I will take minus 12 plus 256 plus 60 will give you 304, and that will be 4A will be equal to 304, and from here A will be equal to 304 divided by answer divided by 4 will give you 76. So 76 kilo Newton. Now you have this force. So what we will do is that we will calculate this B by using another equation of equilibrium, is that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So A, which is upward, so 76 minus this 80 multiplied by 1.6. So 80 multiplied by 1.6 will give you 128 kilonewton. So this is minus 128 plus this B is equal to 0. So from here you will get this 76 minus 128 will give you minus 49. Oh, sorry, 128, not minus 52. So B will be equal to plus 52 kilo Newton. Okay, now we have these two reaction forces. So what we will do is that we will move toward shear force and bending moment diagram. So for that I have to draw the vertical lines from the end of this beam. Okay, and first we will draw the shear force. So for shear force I will need a horizontal line to show the length x in meter, and on y-axis you have shear force having unit kilonewton. Okay, so starting from A, I will write shear force. So starting from A, as you can see at point A, we have A force vertical reaction which is 76. So we can write it as VA is equal to 76 kilonewton. Now from region A to C, you can see there is no load between these two, so it will remain same. So V shear force will be equal to 76 kilonewton. Okay, at region of D, okay, from C to D and at point D, this shear force VD will be equal to, it will be equal to here at this point, the shear force will be equal to VA plus this one. You can see this 80 multiplied by 1.6 will give you shear force at this point. Clear? So I can write it, it will be equal to 76 minus 80 multiplied by 1.6. Okay, and that will give you 76 minus 128, so it will give you minus 52 kilonewton. Okay, so VD is equal to minus 52 kilonewton. Okay, from D to B, and you can see from D to B there is no load, so shear force at point from D to B will be equal to minus 52 kilonewton. Now you have all these values, so let's move and draw the shear force diagram. So for that I will take the scale. So we take one division is equal to 25 kilonewton, so it is 50 and this will be 75, and same is the case minus 25 and minus 50. Okay, first at point A we have shear force of 76 kilonewton, so it will be somewhere here. So let this is 76. Now moving from A to C, this is your point C. Here, so from A to C you can see the shear force remains same, so it will be like, it will be horizontal. Okay, now what is the shear force at point D? So it is minus 52. So D point is this point. So I can write D is minus 52. So it will be like this. Okay, minus 52 kilonewton. Now you can see that shear, the distributed load is a horizontal line with 0 degree. So shear force will be 1 degree higher, and it will be a straight line by joining these 2 points, and slope will be decreasing because this force load is downward. Now from D to B there is same shear force which is minus 52 kilonewton, and at the last you can see you have B which is plus 52, and that will bring it to the 0. So this will be your shear force diagram. Again you can see that at this point you can see the shear force is 0, and at this point you will see in a while that bending moment will be maximum. So what we will do is that we will find the location of this point from this end. For that I will let this distance, and the distance, this distance is taken as x. So this is x. So distance from this point till this point D, this will be equal to how much? So you will see that the total distance is 1.6. This is x. So this will be equal to 1.6 minus x. Now what we will do is that you can see you have two similar triangles. One is this one and another one is this one. So the ratio of their side must be equal to 0. So I will take x divided by 76. That will be equal to 52 divided by 1.6 minus x. So let me write it. X divided by 76 is equal to 1.6 minus x divided by 52. So from here 52x is equal to 1.6 times 76 minus 76x. So 52x plus 76x is equal to 121.6. 1.6 multiplied by 76 is 121.6, and 52 plus 76 is 128. So this will be 128x is equal to 121.6. So x will be equal to 121.6 divided by 128. This is 128. So you will get x will be equal to 121.6 divided by 128. So it will be 0.95. So x is 0.95. And that will be from this till this. So 1.2 plus 0.9 will give you 2.1. So this is 2 at a distance of 2.1 from point A. The shear force will be 0 at that point. 0.95. This is 95 meter. Now we will move toward the bending moment diagram. And for bending moment diagram, we know that for bending moment, let me write it. Bending moment can be obtained by taking the area under the shear force diagram. So area of shear diagram. Okay. So first area you can see from A to C. So this is your point A, and this is your point C. So this is the first area under the shear force diagram, and this is rectangle. Clear? So its area will be 76 multiplied by this length. So this length is 1.2 meter. So I can write it from A to C. The shear force will be, the area under the shear force, which is represented as integral of B into dx, that will be equal to 76 multiplied by 1.2, and that will give you 91.2 kilonewton. You can calculate it as well into meter. Now from C to A, first we will calculate this area from C to E, and let this point is E, where shear force is equal to 0. So from C to E, this is the area under the shear force diagram, and you can see this is a triangle. So its area will be 1 over 2, this height, which is 76, multiplied by this x, which is equal to 0.92. This is the value 95. This is the value of x. So integral of V into dx will give you bending moment, and that will be equal to 1 over 2, 76 multiplied by 0.95. And that will give you the value equal to 36.1 kilonewton into meter. Now from E to D. So this area you can see E to D. So this is the, E to D area under the shear force is this one. And again, this is triangle. So its area will be 1 over 2 multiplied by 52 minus 52 multiplied by this length. And this length will be 1.6 minus 0.92. Okay. So I will write integral of V into dx will be equal to 1 over 2 minus 52 multiplied by, if you take 1.6 minus 0.95, that is 0.65. So I will write 0.65. So multiplying this, we will get minus 16.9 kilonewton into meter. And the last area is from D to B. At the end, we have point B. So D to B is this portion. So area under the shear force diagram is rectangle. So you can see this will be minus 52 multiplied by its length is 1.2. So I will write it from D to B. Area under the shear force diagram is minus 52 multiplied by 1.2, and that is equal to minus 62.4 kilonewton. Now what we will do is that we will draw the bending moment diagram. So for bending moment diagram, again, if I extend these lines, so I will draw a horizontal line to show the length in meter, x in meter. On y-axis you have movement having unit kilonewton into meter. So you can see at point A we have been given bending moment MA, which is 60 kilonewton counterclockwise. So while drawing, remember that while drawing counterclockwise movement on bending moment diagram, it will cause it to go downward. So we will take each division as, for example, 30. So this is minus 20, minus 40, sorry, and minus 60. Each division is 20. So your first point will be this one. So this is bending moment at point A. Now what will be, I will write it, MA is equal to minus 60 kilonewton into meter. Now this is your point C. This is your point C, this is your point E, and this is your point D. Okay. So what we will do is that moment at point C, MC, will be equal to MA plus area under the shear force diagram from A to C. So I will write minus 60 plus 91.2 will give you moment at point C, which is 31.2 kilonewton into meter. So we will locate it. This is minus 20 plus 20. This is plus 40. This is plus 60. So 30 will be somewhere, 32 will be somewhere, 31.2 will be somewhere here, 31.2. Okay. And you can see that the shear force is a horizontal line with 0 degree curve. So bending moment will be 1 degree higher and it will be a straight line and slope will be increasing. Okay. So this was moment at point C. Now moment at point E is equal to moment of at point C, which is 31.2 plus area under the shear force diagram for C to E, which is 36.1, and both of this will give you 67.3 kilonewton into meter. So at point E this will be 67.3. So let's say 67.3 will be somewhere here. I will take it approximately 67.3 kilonewton. And you can see that shear force is a 1 degree line and slope is decreasing. So bending moment will be a 2nd degree curve. It will be like this and in clockwise direction. Okay, now bending moment at point D will be equal to bending moment at point E. Why at point E? Because you can see at point E this is the bending moment. So at point D will be equal to 67. I will cut it instead of that. I will write 67.3 plus area under the shear force diagram from E to D is minus 16.9 kilonewton, and that will give you 50.4 kilonewton into meter. So at point D it is 50.4. So let's say 50.4 will be somewhere here at this point, 50.4. Again, you can see that shear force is a single degree, 1 degree line, straight line, and slope is decreasing. So bending moment will be 1 degree higher and it will be a like curve in this form. Okay. And the last area or moment at point B is equal to moment at point D, which is 50.4, and area under the shear force diagram from D to B, which is minus 62.4 kilonewton. That will give you minus 12 kilonewton into meter. So it will bring it to minus 12. So minus 12 will be somewhere here at this point. You can see this minus 12 will be somewhere here. This is minus 12 kilonewton into meter. And shear force is a horizontal line with 0 degree and this area is negative. So bending moment will be 1 degree higher and it will be a straight line and slope will be decreasing. But at the end you can see you have a bending moment of 12 kilonewton, into meter, that is clockwise. So while drawing a clockwise moment on bending moment diagram, it will go upward. So minus 12 plus 12 will bring it to 0. So this will be your bending moment diagram. Now in second part we have been asked determine the maximum normal stress due to bending. So again we can say that maximum bending stress is equal to maximum bending moment absolute value divided by section modulus. So what is the maximum bending moment? So maximum bending moment, from the bending moment diagram you can see this is 67.3 kilonewton into meter. Okay, there is a meter sign as well, and that will be equal to 67.3 into 10 raised to power 3 Newton into meter. What about section modulus? So Sx can be obtained from the appendix of this book. I will move toward the appendix. So you can see at appendix C, property of roll steel. So you have to move SI unit W. What was given? W 250 multiplied by 80. So W250 multiplied by 80 will be somewhere downward. Okay, now you can see on this page. First you have to be very careful. You have to see, W250 by 80. So W250 is this and 80 is this. So on that you will go to 983. So 983, but you have to go upward. And this is 10 raised to power 3 cubic millimeter. So I will write it 983 into 10 raised to power 3 cubic millimeter. Let me check it again. 10 raised to power 3. Okay, yes. So in meter it will be equal to 983 into 10 raised to power 3, and it will be 10 raised to power minus 12 cubic meter, and that will be, so the 10 339. This is not 12, this is minus 9. Okay, so 983 into 10 raised to power minus 6 cubic meter would be Sx. Now you have both the value, just plug it. 67.3 into 10 raised to power 3 Newton into meter divided by 983 into 10 raised to power minus 6 cubic meter will give you maximum bending stress. And this maximum bending stress will be equal to 68.5 into 10 raised to power 6 Pascal, because Newton per meter square is Pascal, and from that if you want to get it megapascal, so it will be 68.5 megapascal, and which is the answer of our second part. So this was all about this problem 5.58. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also, give me your valuable feedback by commenting on my videos so that I may know how my videos are going on. Thank you.